Zoex.net. Lesson 5. Boolean expressions. Boolean expressions are used to control the flow of a program. They make all the logical decisions inside the code. This lesson will present the foundation of what is needed for programmatic decision-making and give a few examples. This first program demonstrates the various comparison operators in PHP. I begin with 3 variables, 2 integers and a float. Notice that the float is created by simply adding a 0.0 to the 10. This changes the type to float and has implications for how the data is handled. I begin by performing a series of operations to compare the values of 2 integers. These operations are less than, greater than, less than or equal to, greater than or equal to, and not equal to, respectively. Below that, a series of equality checks are performed on the float and integer values of 10. The first check is an equality check like the one I did before. The next one is called an identically equal check and checks the type as well as the value. After that are the not equal and not identically equal checks. For the final operation, I create a new integer 10 using all uppercase letters. Recall that this creates a different variable than the other integer 10 because variable names are case sensitive. Executing the program, the first set of operations give us the expected results. Recall that true is displayed as 1 and false as an empty string. In the next series of checks, the float and integer are determined to have the same value because a conversion is done before they are compared, but they are not considered identical because they are not of the same type. The next 2 operations are just the negation of the previous 2. Note that this not equal is the same as the previous not equal operation. Finally, when we compare the 2 integer values that are 10, we see that they are determined to be identical because they are both of the same type, namely integer. In this next program, I introduce the Boolean logical operators AND, OR, XOR, and NOT. These operators take Boolean values and return a Boolean value. Note that the double ampersand and are both the same operator. Likewise, the double vertical bar and OR are the same operator. The AND operator returns true only when both of its arguments are true. OR returns true when either of its arguments are true. XOR, or exclusive OR, returns true when exactly one of its arguments is true. Finally, the NOT operator returns true when its argument is false. Note that AND, OR, and XOR are binary operators, that is, they operate on 2 values, while NOT is unary and operates on only 1 value. Executing this program, we see that AND is false and the OR and XOR are both true as expected, because they are applied to a true and a false value. For the NOT operator, I applied it to both true and false. This is pretty straightforward if you are familiar with logic, but the next program will clarify this further. This program creates a truth table for each of the logical operators. For each of the binary operators, there are 4 possible combinations of values. For the unary operator, there are only 2. This code creates a total of 4 truth tables. Executing this program, we see our 4 truth tables and the Boolean values that each combination generates. Let me note a few things that might not be apparent. For the AND operator, if the first value is false, the whole expression is false. Similarly for OR, if the first value is true, the whole expression is true. This leads to some potential optimizations that we should keep in mind. If our code is evaluating these expressions, it does not need to evaluate the second expression in these cases, and it will not do so. You can verify this by changing the variable name in the second expression and seeing that it does not care. To prove this, I will change these false variable names in these 2 entries of the OR table. Only the second instance gets reported as an undefined variable because the first one was never evaluated. Notice also that the second one is reported even though its final value is exactly the same, true. That's interesting, isn't it? This final program creates some mathematical expressions. To start, we have 3 float variables, x, y, and z. Below this, I put together some Boolean expressions to check whether a value is contained in an open interval. After that, I put together a Boolean expression to evaluate an absolute value expression. Executing this program, I have 1 line to explain what is being checked and 1 line to perform the evaluation. Since y is between x and z, this expression evaluates to true, but notice that it was evaluated by putting two comparisons together with AND. Below that, I test whether x is in the interval between y and z. It isn't, as the value indicates. Finally, I check whether the absolute value of y minus z is greater than x. This is done via two checks that are joined together by an OR. This evaluates to true because y is less than z minus x. These are simple expressions, but they hint at the power of Boolean expressions. In practice, you can put together numerous values and join them together to design incredibly complex Boolean expressions.